popular thing to go like drive around the town and like look at everybody's lights. What?
My grandma lives in Tucson.
Really?
And, yeah, my entire family.
We had this conversation, haven't we?
Yeah,
Does she live in Roscoe?
Huh?
Or where's she live?
My mom lives in Warsaw.
Yeah, where's your grandma live?
Warsaw.
Warsaw. So there's a really good ice cream shop up there.
Yeah, there's ice cream down there.
Yeah.
Let's go to ice cream here.
See Mountain Drive.
Yeah.
Yeah, my grandma lives in that hill with the star on the
That's
house.
oh yeah, I know exactly where that is.
Yeah.
All right, so did we get through this example?
We didn't do the God.
And we're right here. Yeah, that's what I thought. Okay, let's dive in. So to figure out which expressions are equivalent, we got to figure out what this expression is. Oh, by the way, I had 2 papers I forgot to pass out because I was going to try to grab these people at break or whatnot. I know, not today. I've been waiting, but they weren't in AOs or things where I could get them. And I just need you to practice sometime, so that's going to have to happen during school. The chapter 3, but just Monday, come finish it. So, what is it that we said that's weird or like special or particular about when we have a subtraction between my expressions? Sean? Yeah, like, what would it be to do to each one? We distribute the minus or the negative or whatever you want to call it. So, go ahead and right here on your paper, draw arrows. And actually, a lot of times will just above it write, okay, so that means minus 4 and plus 8y. Because the opposite of 4 is a minus 4 or a negative 4. The opposite of minus 8 is a plus 8y. Any questions on how my distribution of the minus turned my 4 negative and my 8y positive, or into addition? So then, what didn't change is the 6y plus 15. Because the 6y plus 15, nothing happened to that expression yet.
So would that be addition now?
So now I can just combine the like terms. I combine my variable term with my variable term and my constant term. Oh, come on. Give me a highlighter. My constant term with my constant term. So I know I'm working up instead of working down, but I have no space to work down. My variable terms, if I have 6y and 8y, I end up with 14y. And if I have 15 minus 4, I end up with 11. So really, I'm looking for expressions that end up with 14 y's and 11 as my constant value. So let's look down through here and see which ones work. If I combine my y values here, will I get 14y? Honestly?
Yeah.
So if I have 8y and then I subtract, if I have 6y and then I subtract 8y from it,
Oh, no.
here's the trick, and this is where people make their mistakes. The sign in front of the term, or really to the left of the term, goes with it. So if I rearrange this, this would be 6y minus 8y plus 15 minus 4. So this would not give us 14y because of this negative or that minus. That does not work. Option 1 is out.
So that means 2 new words.
You know what's
So hold on. Question.
an easier way to figure out that one wouldn't work?
I would much prefer you say another way, because easy is relative.
Okay.
Easy in your brain might be really complicated in somebody else's brain. So another way,
You could have looked at even the 6y plus 15 minus 4 plus 8y.
what?
Right there. You wrote it.
Yeah,
Yeah.
but we're trying to compare to a different expression.
Exactly. So if you just look at this,
So what you're saying is because this is minus and this was plus, it's going to be different? But me as a teacher, I'm trying to get you guys to practice combining the like terms, not just identifying differences. Third graders can identify that has that symbol and that doesn't. We're practicing other skills. So, looking at 2, what happens when we combine a 6y and an 8y? We get 14y. What happens when I combine a 15 and a minus 4?
11.
We get 11. So does it work? It does work. Try 3 and 4 on your own. Figure out how many y and how many constant you would have. Cards. So, Acadia, when you look at number 3, anything jump out at you? Why does that jump out at you? Yeah, I agree. So we had a minus up here, whereas here we have a plus. But also down here we have a negative 1. So is subtracting a value the same as adding the negative of that value? Yeah. Number 3 is just applying the property that we saw further up in your notes. That if we have a subtraction, if we have a subtraction, it can really be written as the addition of a negative. A subtraction can become the addition of the negative. So I think it was on our 7.3 notes. Hey Sam, can you put that away, please? I've asked way too many people. I'm getting very tired. I'm going to start taking stuff away. On a set of notes, I think it was 7.3, you should have written down subtraction is addition, and then we put like kind of, and we said it's subtraction of, or it's addition of a negative. If you don't, or if you want a reminder, I would write up here where it says rewrite subtraction as addition, I would remind yourself that subtraction is addition. There we go. Of a negative. And then we got to look at number 4 and see if that one works. Evie, I haven't talked with you yet today.
No, I was going to ask you something else.
Oh.
I've been meaning to ask you this. So, a couple years now, we've been doing S and math, in my elementary school.
Yeah.
Did we do that at all this year?
No. The program is not, the program does not give me enough control. It was using too much time for not enough, I like the program. I got really, really excited about it when it came out. They just need to make some modifications for teachers to control as opposed to the program. Yeah. Now, for what it's worth, I do have a Gigi outfit. So I have a penguin costume. Maybe. Now, so Evie, because do you have the answer, Dom? So Dom, what happens when I combine my variables there? What do we get? Ooh, yeah, so this subtraction of the negative really is a positive. So what do you get when you combine the... You get your 14y. So does it work?
So it says negative 8y.
But minus a negative is plus a positive.
Oh yeah, that negative next to the 8y just completely goes away. Never mind.
This becomes plus
That's negative 4
8y.
plus 8y.
But you can't add negative 4 and 8y.
Oh.
So if I rewrote this whole thing, it'd be 6y plus 15. Adding a negative we clean up to subtraction, minus a negative, we clean up to addition.
That is
We
awesome.
always want to clean it up as we go.
That's like boss right there, folks.
So try this next one on your own. There are, if you do it through the technical process, there are 5 steps here. Drawing the arrows does not count as a step.
So that's one is like just getting the problem.
Well, actually, I may end up with more steps than them. But try to keep your eyes on your paper. If you get stuck, look up here. So I'm going to go ahead and write some stuff out. It's not impossible that I make a mistake. No, but it could. Sometimes I do intentionally. Normally I gotta look on my face that gives it away. But I want somebody to talk through what I've written.
Okay.
Jeremiah, you think you can?
So you realize that, hey, there's a negative in front of the 2. Grouped them together because you realize you have to do that eventually, I think. And then you multiply the negative 2 by 2.7 plus 0.25x because it's in the parentheses.
So the first thing I did was recognize subtraction is addition of a negative. Because we want to assume addition. We really always want to be doing addition. Okay, so I distribute that multiplication. Any questions up until step 3? All I did was show the multiplication written out. That negative 2 multiplies by 2.7, and negative 2 multiplies by a quarter x.
Oh, okay. I'm like, I thought you said 2.025, and I'm like,
No.
what?
2 times 0.25. Normally my multiplication dots are a little bit thicker too. Notice my decimal versus multiplication.
Okay.
So then,
And then you multiply the negative 2 by the 2.7, and then your answer is what step 3 is. And then for step 4, what you did was you used I think you used the commutative.
I haven't used any properties yet actually.
Oh.
All I did was do this and got that.
Yeah.
Do this, got that.
Yeah.
So this was really
Yeah,
simplification.
you just simplified.
So then,
Yeah, that's all you did.
what do I do now?
Step 5, you rearrange it so that you can do 3.5x plus 0.5x, negative 0.5x.
Ah, now, we don't even have to rearrange it because I'm running out of space. I'm just going to identify these are my like terms that I combine. So what do I get when I have 3.5x and I add a negative half x? Anish? Just 3x plus, and instead of putting plus a negative, we can just do minus 5.4. Any preguntas?
That means
Preguntas. I'm trying to get you guys to understand a little bit of Spanish to help Mr. Combs out. Means questions. So, for now, how you would say that in Spanish is ¿Tienes una pregunta? Do you have a question? No. Un poco, señorita. Un poco. Yo tengo 3 años. I knew that was going to happen because it's a nice day. He ended up, when he came back, because he was like absent that day, he's like, well, there was our monthly fire drill. Like that was our October fire drill. It wasn't a drill, but it was the real thing. So it counts as our drill. So this one was intentional. If you're watching the video, you missed a fire drill. So, any questions on this process here?
Good job.
Cool. Good job. So, flip to the back.
Wait, I kind of have a question. Is there like a way you can get that back now?
I thought it captured. No, apparently not.
Okay, then
But
never mind.
what was your question?
How do you choose the way to organize it?
It honestly doesn't matter. Because the commutative property, and there's addition between each of these, like I'll show that on this one, that we can reorganize however, once we distribute and the parentheses no longer matter, we can reorganize however we want. So if we look at this problem, please solve it the way that we're doing it here, which is not going to make Monica happy. But we're going to switch this minus into addition of a negative. So the first thing we want to write is negative 9x plus 15. Nothing changes with that. But then we're going to change our negative
-1?
into addition of negative 1 times the 2x minus 1. Any questions on why we do that?
I think I know why we do that, right?
Here's the
Because you
thing.
still need to apply the minus, but it just makes it easier because you have
We
to...
can't do this. Because you can't just say negative. Because then the question is, negative what? So you can't say plus minus either, because you can't have two different operations happening at the same time. So if we're going to change it to addition, it has to be addition of something, and we can't get rid of the minus. So instead, it turns into negative 1, which will make these values, when we distribute, do what the original minus would have done. But we just want to get familiar with rewriting and why we can do that. So then, still, negative 9x plus 15, nothing changes, and we don't really need the parentheses around it, so you can go ahead and get rid of them if you want to.
That was so funny what we did.
So then, your distribution always, there's addition between. If the value's negative, then make it parentheses. So negative 1 times 2x, we're going to go ahead and skip the step where we show the multiplication. What's the negative 1 times 2x? Well, it just makes it the opposite.
Excuse me, can I have Riley to the office, please, Riley?
Then, negative 1 times minus 1, makes it into addition. These parentheses aren't actually doing anything. So we don't
They just make
need
it
them.
pretty.
Kill him with fire.
Kill it out.
You know you can't kill with fire? Fire.
Or
So now, to answer your question, now, the order, I can do anything I want with this order. So, I only have like 10 minutes left. We can rearrange this however you feel like. We like variable terms to come first. And when we get to graphing lines like that poster back there, it'll make more sense why. But to get my variable terms first, and honestly, we don't have to rearrange it. But the reason we want to practice this, I want to move this because notice now I have a plus negative or plus minus. So I need to move that. Now it becomes negative 9x. Where you go? Ozzy?
is it plus negative 2x?
But we don't need to say plus negative.
Minus 2.
We can just say minus 2x. Then I can have my plus 15, and then my plus 1, because the sign in front of every term is still in front of that term. This minus is still in front of that, which it could have been a minus or a negative. When we had the parentheses, it was a negative. When we took the parenthesis away, it becomes a minus, and this plus sign was really unnecessary. So, any questions with how we did that rearrangement? Dom.
So could you have done negative 11 plus 16? Or plus 17?
Where's negative
Or
11?
would you be allowed to combine the negative 9x and negative 2x?
Yeah, we can. Yeah, we're not done yet.
Oh, okay, I thought we were.
Now we're going to combine our like terms. We got to pretty it up. What do we get when we end?
Okay, so then you do negative 9x minus 2x, negative 11x plus 15 plus 1, 16.
She didn't even say that much. She just talks fast. So, work on slowing down a little bit because when you share and your peers don't get it, it's kind of pointless. Everything you said is correct, though. We combine our negative 9x minus 2x, which takes me more negative, and I get negative 11x. We combine our 15 and our 1, and we get 16. Any questions on how? Sorry, again, it didn't capture. My calibration's slightly off. Oh, nice. Hey, it's just taking a moment. Ooh, by the way, I get a new computer. So hopefully it will speed up.
When?
That's why all the computers in the tech lab just got removed. They came in to try to take my computer, and I was like, no, you can't. I'll chain myself to it. And then they looked at how I teach and like, okay, we'll make you a desktop. So they're going to build me a desktop specifically for how I teach. Hopefully things speed up.
Why do you think? Yeah, my dad.
The cheapest way to make a computer is build it out of parts. It's not that hard. We can talk about it some other time. Go to the tech lab and learn how to code. You'll be ready. And you don't even need to know how to code to make a computer. It's just a really good launch pad. So, see if you can set this up with an expression. Two friends shop for fresh fruit. Jackson buys a watermelon for $7.45 and 3 pounds of cherries. We don't know what the cherries cost, but that's what Jackson buys. So Jackson's going to buy a watermelon for $7.45, 3 pounds of cherries. Aaron buys a pineapple for $3.50 and 2 pounds of cherries. So set up each of them as their own expression. Then we're going to try to combine the expressions. Katie, are you with me?
What are we trying to make?
You are trying to combine everything they bought together.
Oh, okay, gotcha.
I could just take cards out when we have a fire drill, I guess, to figure out who's here and not. So, Mr. Williams, if I were to ask you the expression for Jackson, what expression did you write for what Jackson purchased?
No, but I have the answer. I just haven't written it down.
Okay.
I believe it's so 7.45 plus 3C.
Yeah.
Cherries.
We don't know what the cherries cost, so we just represent. Huh? I don't care what variable you use.
I put P for price of cherries.
Sure.
I put C because that makes sense.
Samantha, for Aaron, what would his expression be?
$3.50 plus 2C.
So, Mr. Smith, why is your hand up?
Oh, because for Jackson, I put W plus 3C. Is that hard?
No, because we know the price of the watermelon. Remember, we go back to your definitions. A constant is a known value. We know this value, so we go ahead and write it. We don't know the pounds of cherries, like what that costs, so we have to use a variable for that. Does that make sense? We wouldn't put a variable for something that we already know. So now when I go to combine these, this one's easy because we have addition between them. So is there anything that needs distributed? No. So honestly, if you have highlighters, you can just color code, but I've already color coded up there, so actually I'm just going to connect with colors. Samantha, what would add together here? So if I do pounds of cherries, what do I get? 5C. And if I do the cash that they spend, you know what?
290. Oh yeah, you're right.
So then, once we know what the pound of cherries costs, we can figure out their total price. Bless you. Any questions?
I have a question.
Yeah.
What would happen if Monica drank coffee?
Huh. Who knows? If you drank coffee,
I'm not allowed to drink coffee.
I wonder why.
You can use your monster
I've never had
You know, actually, some people, caffeine has the reverse effect.
Yeah, it
Like-
makes me
That's
tired.
me.
Yeah.
I drink
But-
I still have it though, 'cause it's good.
Yeah, it tastes good. I feel this.
So, now, this is a challenge. I want you guys to take a couple minutes on this on your own with your partner group. Now, hold up. Listen. Here's what we're trying to do. We want to find the area of just the shaded region. So, if somebody was going to, don't use numbers, don't use variables. If I was going to ask you how we could do this, Julian, what do you think? I don't want numbers, I don't want variables. In general, how could we find the shaded region?
Oh. Add all of the perimeter of the shaded region.
Perimeter. We use perimeter for area.
Oh.
So I'd much prefer that you focus on what we're doing instead of how you can look through your pencil. Hoover.
Alright, so
Don't give me numbers or variables. I just want in general, how are you going to do
yeah,
this?
you're gonna find the area of the, we'll say that's a table and carpet. We'll find the area of that and subtract it from the area of the whole.
So Andrew just made a model. He said, I'm going to envision that this is a carpet with a table sitting on it. And he said, I'm going to find the whole area of the carpet and then take away the table.
That's a good idea.
Which essentially what I was thinking was big rectangle minus small rectangle. But if you can visualize something, it makes sense. So maybe we're answering how much of the carpet gets walked on. And if it's under the table, it's not going to get walked on. So set this up. I'm going to give you a couple minutes to do it on your own. Set this up and try to solve an expression for the area of the shaded region.
That's shady.
Nope, you can't assume. We don't know what x is, and we can't know what x is. There's no way for us to figure out what x is, so you have to use it as x.
I think I got the area of the carpet. I can figure out the area of the carpet. I think the area of the carpet is 6 inches square. I measured it with a 2-inch scale.
It's not on the scale.
Not to scale. You can't figure out x. You can't. Impossible. No, you can't. It's not to scale. You cannot measure. We're using the variable. You can't figure it out. So,
Oh wait, oh no, that's
oh, is it magic?
I think you need to be whatever you do it when you reach the
Huh?
to the board. I
Oh, orient.
Yeah, I think you need
Yeah, I know. We're at the end of the day on Friday. I'm going to see who's... Ashley, I'm going to have multiple people help me solve this. Ashley, when you looked at the big rectangle, or what we're calling the carpet, guys, refocus. So, did you figure out what this long edge is? Anyone? Whitney? I got 2 here, I got 6 here, and I got 2 here. So that is 10 inches. So I know it's going to be 10 times something, but then this height, go ahead, Whitney.
I was going to say that height is 6 inches.
You don't know what x is. You don't know this amount of space. It's 2 here and 2 here, but we don't know what the whole height is. We can't figure out what x is, Ashley. It's x plus 4, because I have this is x, 2 here, 2 here. So I'm going to multiply my 10, parentheses, x plus 4. Because to find area, it's length times width. And my width is an expression of x plus 4. So, are you going to keep working the red, or are you going to move to the blue?
I'll do all of it.
Well, I don't want all of it. I'm doing pieces, parts. Julian?
Yeah, I got the rest.
So, can I do the blue?
Sure.
Okay, so for that you would do 6 times x, because that would be the inside of the table.
My length times my width. This is just 6 times x, or 6x. So when I look back at my red, Manasa, what do I get when I look at my red area?
So here what you need to do is you need to do 10 times x. I'm trying to slow down.
I appreciate that. I've had to work on that as well. Yeah.
And then you also need to do 10 times 4. So you get 10x plus 40.
Thank you very much. The thing is, people want to hear what you have to say, but when you talk very fast, they don't have time to hear what you say. Jeremiah?
From there. Oh, I just realized you could solve even further than that. I thought it would end there. My bad. I don't know what I'm talking about.
Well, what do you mean you can solve further? How can we solve further?
So from there is 10x, but also 6x, which are like terms.
6x?
Negative
6x, because the sign in front of it belongs to it.
Okay. And so you would take 10x and add negative 6x. And
All I did was the commutative property, by the way. I just moved to clean it up.
And that is 4x plus 40, yeah. And that's your dimensions of something.
So now, if we figure out how wide the table is, I can figure out the area of the shaded region.
There you go.
We will just stop there, and we will do 7-5 on Monday. Thank you guys very much. Have a wonderful weekend.
I guess Olympians.
And honestly, if you guys want to go ahead and do 7-5, you probably can. Like, you're probably ready for it.
You know what's funny? So I'm eating 2 Olympians.
Who are, like, what Olympians are?